Hello everyone, welcome to the Tech Hench. Today we are going to start a new series to explain use of Dockers and automation. We'll cover various topics in this series. First and foremost, definitely should be what exactly Docker is, why it is used, how it is used, and advantages of using Docker and automation. So we'll discuss uh, these topics in upcoming videos. So for today, let's just discuss what a Docker is. So before understanding Docker, let us focus on the problem that developers used to face before Docker and the advantage this has brought to actual development and deployment processes. So let's just quickly discuss an example where, say, for example, you want to develop a new application. We'll discuss the life cycle of that application. Say, for example, you want to create a new application, an e-commerce application named ClickCart. So, in order to develop this application, you might need different items or different dependencies to be set up in your system. Say, for example, to develop front end of this application, you might need React.js, and for styling purposes, say for example, you choose to use Bootstrap. Similarly, for backend, you may need Node.js or Java. Just taking any examples, and for you might need something for databases. So everything of this needs to be set up before you start actual development of your product. Okay, say you set all this up in your system and you start developing for your project and you complete the code of this project, and this is now with you on your system. And after this, uh, you would have to, in order for people to use it, you would have to host this on a physical server or maybe a cloud machine. Uh, this would be any, most probably Unix or a Windows machine where you would have to, set up your project. So in order to get this running, what you would have to do, the same sort of items that you set it up on your system first, that has to be set it up on the server itself before uh, before making your application live. And this setup would have been again, similar in terms of their configurations, their versions, so that your application runs as in equal as it works on your system. So this becomes developers or the one who deploys it, his responsibility to get this done. So say you set it up on your server as well, and then maybe using the normal CI/CD cycle, say you maintain the project repository on Azure reports, and you might have, added some pipelines, deployment pipelines to get this code deployed to the server every time you push something to it, right? Every new features will be pushed. This is the first cycle, say for example. This way, your application is live now. Now, say load of users can interact with your applications, whatever the core logic is. Since this is an e-cloud application, everyone would be able to use this now. So the key point here was that every single dependency or say for example we used, there would be n number of them, but we say for example we have discussed only for, say for example, Bootstrap or Node.js or uh, Postgre database. All you would have to set up every time you get this running on a machine, right? So this could bring a challenge in terms of, say for example, new members are added to your team. The product has grown, new members are added to your team. Now, say for example, this becomes, more load of user is using, and you are operating in different regions, so different servers have to be set up. So in case different set of servers has to be set up, those servers should also have the same set of configurations created, or same set of these items should be set it up over these replica servers as well, so that they can act in the same way, right? And say for example, these new developers who are here need to work on new functions of this particular product, what would they do? They're on their own local machines. What would they have to do? They would have to do this setup again, set up these services before getting the actual code and start developing or making new changes to that code. So what, say for example, these two developer are setting this manually, and what happens that they might added one of the incompatible versions, or made a sort of configuration, or con they change the configuration of any of these before setting up, that might not be compatible with the click card code. What would happen is, like, uh, since their setup is fine enough, but even after that, if they will take repository, take clone of this product and they try to develop on it, they might encounter errors in terms of incompatibility issues. So this leads to, like, say for example, say they reach the existing dev and they ask him that this might not working on their machine, but when the dev who actually the first developed the machine has the exact versions of the dependency that were required for that, says that it works on fine on his machine. So this is rise to a classical example, that error that people used to face before Dockers, in terms of bigger applications. So the responsibility of setting up dependencies or everything that is required for start starting development is one user's sole responsibility, or documents could have been created that what exactly need to be set up, how it to be set up, but that used to be a tedious process. To solve this up, what could have been done in a different way is that we could the dev could have used the concept of Docker. So what Docker says is that, it helps us with containerization. Now, what containerization is? Containerization enables ones to, pack things, pack things like environment along with the code in single small containers, so that they take all their dependencies together along with the code, so that it may work the same way that it works for one user will work the same way for the different user. Say for example, in the containerization, all of these are packed in one container, and that can be used to develop application. But container is something is a small enough, should be a small enough service to be supported. So in actual process, what happens is everything is packed into different small containers that can be clubbed together, and Docker manages those container to justify an application that we have an action. So this is like everything, every single dependency, or what exactly that all of these four React.js, Bootstrap, Node.js, and data PostgreSQL that is required to set up this app, and along with the app code as well, has to be set up. Is packed in a different containers, and these containers are small enough to be shipped or clubbed together, and which forms the entire application. So considering this is an application now, what user need to do is, since every environment and everything is set up or packed together with, it can be maintained as repositories, and with deployment pipelines it can directly be set it up on the server. So the server itself, or the new machines, server in this case, do not require you to set up all those again or define all those again. This has the entire information. Everything is packed together. What dependencies are required to for this to be running. Everything is packed up together so that it can run, in a unified way. So this way, the need of setting up the environment, of setting up the various dependencies for this product to run is eliminated, and on in order to replicate it on different servers, the same can be deployed. This way, again, user won't, this is same for the end user again. they can interact with the server, and these you know containerized product can act in the same way that the earlier application was acting. See, for example, in this case, new developers are added. So what would happen? They won't set up anything on their own systems. What they will do, they will direct clone this, and when they will run the containers, everything would be set it up accordingly on their systems, and the code would run perfect as would have run on the first developer's machines. So this gives a win-win situation that code runs fine and eliminates the extra efforts on just setting things up. One can focus more on development instead of resolving simple version issues. So this is how Docker came into concept. So let's just discuss on key points of Docker. We have discussed all of this. Like, Docker is an open platform, gives an open platform that supports containerization. We discussed what containerization is. You can pack your different services in different small containers, and all those can be carried with a Docker, right? So it helps with development, shipping, and running of those applications. We saw with the, discussed the example. Docker provides the ability to package and run application in a loosely isolated environment called container. So container is a loosely isolated environment. For every different service, you might have one container, and those can be clubbed together to run accordingly with the applications. And this runs whosoever using the same container, it would work the same way for all the users. So Docker's approach is to shipping, testing, and deploying code greatly reduce the time between development and production, since this eliminates the error of setting things up manually, or keep resolving the issues with the different versions. So this actually reduces the time of deploying things up. Docker makes scaling by using lightweight containers, allowing applications to grow quickly and handle more users as needed. So if, for example, I mean, in this particular application, if this grows and we might need to use, a different set of bundles, or maybe we had to expand database to this, more containers of the same service can be added to quickly scale this application. So this helps in scalability as well. It ensures that application runs seamlessly across different computing environments, where it's in developers' laptops, staging environment, or production servers. We saw that, like, it was very easy for anyone to set up the application on the server, or for new development members added to the system, it was easy for them to set up the Docker. So this is all about what Docker is. In upcoming lectures, we will discuss about Docker images and containers in elaborative way, and then in following videos we will discuss on um, the need of Docker in automation testing, and what type of containers or Dockers we are container images we are using there, and we'll do a practical example of running automation scripts on containers. So this is all for this video. If you like the video or like the content of this video, please do subscribe. Thanks for watching.